Mm.
Charging your EV in 30 seconds.
So, hi everyone, I'm Satyan from Intelligence Innovations. The company is called Intelligence Innovations Private Limited. The product that we are building, we are calling it as a Magic Stop. With Magic Stop, our goal is to build the fuel pump of the future, right? So, this is the vision that we are after. That's what will the fuel pump of the future look like, and are we the ones to build it? So the problem today is that there is more or less a general consensus among people that EVs are the future, right? From the government bodies to the end user, everybody wants EVs to be the future, but in the current state, it's not possible. Today's EVs cost 30 to 40% more than the petrol counterparts, which is mainly due to the high cost of batteries, right? And second and most important problem is that long charging times. And we believe that once EVs are ubiquitous, people wouldn't even want to wait 15 minutes at a charging station on a regular basis, right? So to solve this problem, we have developed Magic Swap. Magic Swap is a petrol pump equivalent for electric vehicles. So the way this works is that once a customer's EV is low on charge, instead of them waiting several hours at a charging station, all that they have to do is come to our station, take a cable from the station and connect it to the port in the EV. Now what happens internally is that all the discharge cells from the EV's battery pack are pulled in through the cable and are replaced by fully charged cells from the station. This entire process takes 30 to 40 seconds. The customer feels it's a high-speed charging and they can continue in the journey to full charge, right? Now the advantage of us swapping cells from EV's battery pack is that the way I can swap say 100 cells from an electric scooter, I can do 140 from an electric bike, 180 from a bigger bike of a different OEM, 300 cells from an electric auto, and so on. Hence, it's a true replacement for petrol pumps in the EV world, wherein any vehicle comes to the station and goes from 0 to 100% charge in seconds. Coming to the business, yeah. Yes, sir. So coming to the business model, this will this not just be a physical separation of the battery pack from the EV, but also a separation of ownership. We give this battery pack to the customer at zero upfront cost and charge a subscription model. So now the cost of the EV has come down by 30 to 40% because we have removed the cost of the battery pack from the vehicle, and we are also charging it within 20 seconds. So we have solved both the problems that are stopping EV adoption in India. Coming to the technology, so this entire technology has been ideated from in-house buyers. So that even the term self-swapping has been coined up. Nobody in the world is trying to swap cells because evidently it's super challenging. Right? When we got the self-swapping idea, it was not just that okay we can put 5 10 components together and make it happen. We had to develop every single component that goes into the system from scratch. Right? There are no batteries to get into the cells. Once the EV goes on the road, how do you ensure that these cells give enough current? Once you have to pull the cells in and out, then how do you make connections happen, right? So say there's an electric scooter that has 200 cells. 200 cells means 400 positive and negative connections, and even if you're off by 5 out of one of those, it can burn the entire battery pack. Right? So it's an extremely complex problem, and to solve for which we have to develop every single component in scratch. And over the next 3 months, we'll be looking to file 7 to 8 patents to close our entire IP, right? And again, a lot of IP, the cable and stuff. So when you wanted this swapping to happen, we want the same petrol-like experience. We didn't want a good robotic apparatus to swap the cells, so we built a swapping cable that allows the cells to move in and out, but we still feels organic enough like a cable. Coming to the competition landscape, today EVs we are all familiar with slow charging of EVs. They take 5 to 8 hours at our homes, right? And then there are companies that have set up DC fast charging stations like Tata Power, Static, etc. These take about 60 to 90 minutes to charge today. Now, the way the future outlook looks like in the startup world, we have companies like Exponent, Clean Electric, etc. coming up with the rapid charge technology, essentially doing a 15 to 20 minute charge. Right? Even Tesla is around 20 minutes today. And this is more or less what will look like for the next 6 to 7 years. Is that 15 to 20 minutes charging speed will be the maximum, which we still believe is not enough, right? Once, especially in infrastructure point of view, also if you want a car sitting in the middle of a city occupying heavy real estate for 20 minutes, you can't possibly make a ROI from that, right? And then there's this other group of startups called battery swapping companies like Sun Mobility, Ample Energy, where you go to the station, physically remove the battery pack from the vehicle. You have a station that has multiple cabinets. You put your dead card in one of the empty cabinets, take a fully charged battery from a different cabinet, put it back into your vehicle, and vehicle is essentially fully charged. So they have also cut down the time from several hours to a few seconds. But the problem with these companies is that you have to fix the size shape capacity of the battery pack. So the same size battery pack that you took out, you have to have multiple copies. You can take it back and put it back in, right? So now, because of the standardization problem, you can't offer the swapping solution for every single vehicle model. The battery that you're putting in a scooter, you can't put in a car, right? Car won't give you 5 kilometers of range for the battery. And hence, now to scale up this model, you will have to build a different petrol pump for every single vehicle model, which is not possible. But what we are doing is any number of cells, any fuse and parallel combination can be solved at our stations. So essentially summarizing the computational landscape, the way every other technology today in the world works is that they have one of two key features required to build a petroleum equivalent. Either they have high throughput, so essentially with manual swapping they can do it very fast. They have high throughput within 30 seconds, but they're limited by the number of vehicles that they can cater to. Or with this charging, you can charge any vehicle from the same charger, but you're limited by the charging time, right? 50 to 60 minutes. We're the only technology in the world that can do both. We can do a 30-second swap for any vehicle, and hence we're the only company that's poised to be a petroleum equivalent for the future. Coming to go-to-market, we're initially targeting commercial operators, essentially last mile fleet operators. And with this, the advantage is that we don't need to start with a network of stations in a city. I can just set up one station next to the warehouse and sign up 40 vehicles to our fleet. And so in this initial target, we have companies like Let's Transport, Loadshed, blah, blah, blah. All of these companies essentially do last mile deliveries for other companies like Amazon, Flipkart, and Zeptos of the world. We have already signed a pilot deal with Eco Group. Eco Group has about 150 vehicles in their fleet right now, and have recently signed a deal with Uber to expand it to 2,500 vehicles, and will be part of the deal. By now, I think, since in the interest of time, it's very clear we started growing right now. We are a team based out of Bangalore. I had started this startup in January 2019, building autonomous drones back then. We won lots of awards in transfer tech, but started to pivot because autonomous drones wasn't legal in India back then. Worked on building helmets and slow bounce and mogo bikes, and since then we understood the problem and started to build this. Over the last 2 years, we have essentially gone from doing it on a cycle that we can remove the cells, because back then in the world nobody had tried it. And now we are at a point where we have proved our technology, and now we are working to commercialize it, for which we are looking to make product changes to get the necessary certifications and then launch on the road. So essentially that's my pitch. We are calling the technology Magic Store because any sufficiently advanced technology is indistinguishable from magic. Thank you.
That's amazing. I'm actually quite impressed by the almost invention that you've done. A few questions. What is your business model? I mean, the petrol pumps go on a subscription model, so do I take a subscription on a monthly basis? How does that work?
Yeah, so now you as an end user, say you're going to buy a bike, right? Earlier you have bought an Ather bike for say 1.4 lakhs.
Yeah.
But with us in the picture now, you will only pay 1 lakh for your Ather bike. You will buy the bike without the battery. So you save 40,000 on the capex which you should have paid for the battery. We put our battery for free and into your bike. Now you're logged in a subscription model. You'll pay us a monthly subscription, but you can also come to any of our stations and charge it in 20 seconds. So this is how it works for you as a consumer, but to the normal consumers, we'll be targeting 2 to 3 years down the line. First, it's only for fleet operators, and to them, again, same model, they'll buy the EVs, but they'll buy in bulk. They'll buy 40 EVs without batteries, saving the capex. We put our batteries in them, set up a station next to the warehouse, and then they can run their operations. And essentially, the biggest key factor for the advantage for them here is that until now, anybody that is doing fleet operations with EVs, they are limited by the range. They can only do one single shift in a day. So these vehicles take the package, do about 80 odd kilometer shift, come back to the warehouse, and then have to begin charging. With us in the picture, from the day we launch, they can immediately double their revenues, because they can come to the warehouse, swap within 30 seconds, again go and do the second shift.
And the other question that I had was, sorry, I was going to
I have one question. How do we come to the bike showroom at home before riding comes?
Yeah, so this will be put in the showroom itself, but the registration will happen before the batteries. So essentially today, you don't need, from August of 2020, Indian government allowed the EVs to be registered without the batteries. So the registration happens without the batteries, but we put it with the battery and give it to you.
I am not able to test whether it is working or not working without the battery.
No, you will be able to test, right? So say, essentially right now we are doing with fleet operators, we're not focusing on the showroom part. With them it is a one-to-one sales-based approach, but the way it will work even then is that you will get the EV with the battery installed from the showroom only, but you don't own the battery, you only own the EV.
Coming to business model, you are competing with EV or depending on EV?
We are partnering with them and depending on
Depending.
yeah.
Isn't it the case that the subsidy that is given for vehicle is on the basis of battery?
Yeah,
But
but
if they sell it without the battery, then how they get the subsidy in this entire, at least for the two-wheeler market, the entire business would collapse if they were to not avail the subsidy.
yeah, which has already happened. So
Correct, exactly.
So these subsidies have already come down massively, right? It was 60,000 until few months ago. Now it is 22,500 maximum, and which will also will trend downwards. So we are building for a post-subsidy world, not for a world where subsidy exists. And even then, it still makes sense because you can avail about 22,500 subsidy today with us, but by removing the battery, the customers is saving out 45, 60,000. So it still makes sense for the customer.
And do you already have ARAI approval for your battery?
No, so this is the step that we are building now.
Uh-huh.
So we signed a pilot deal in June when we finished our first on-road demo product after 3 full-scale proof of concepts. Now we are in talks and we are making changes in the product to pass the AS 156 guidelines, and I think about mid-December is when we would get approval.
So I wish you luck on that, because I think till the time you have ARAI has just upped its upped its requirements.
Yeah,
I mean,
that's
where
why-
they have reduced the packing density in the batteries is exactly what they challenge. Too many batteries were catching fire, so they have upped the
they have
capacity.
inherent advantage because
And here you're talking about taking the cells out, putting cells in. So something which is it's a very hot issue right now about the safety of the batteries. So I think that till you are in a position where you have an ARAI approval, I think it's premature. The conversation in my humble opinion. This is point one. Point two is it seems like a business model which would favor fleet operators. For end user, it would be a very hard pitch, because you will have to essentially make strategic alignments with the vehicle OEM, right? They will have to buy into your,
Yes.
and then you have there's a lot of competition for that space.
Yes, so this is both clear concerns. Firstly, coming to the technology, again, we are very confident on being approved with the AI thing, because over the last 2 months, that's what we've been working on. So we think and like every month, we're looking to solve one or more of those checklist. Like, say we have to add eight temperature sensors, blah blah blah. Every single checklist, we're making changes in our novel battery pack design. So we approve, and then some of the things are doing it inherently better than the competition, better than, so say, as you mentioned, the packaging thing, right? Since we have to remove and put back cells, our packaging thing is inherently lower than the normal batteries. Hence, we automatically are compliant with the new rules. Because if you are making a normal pack, you will smush the cells together using solder and make a pack. Since in the remove process, we have to give space between the cells to be able to remove in and out. So, and stuff like, say the cell, say one of the cell malfunctions, battery catches fire. Since we can remove the connection in between the cells on the go, if we see anything goes wrong, we can immediately remove the pack connection. Now it is just a dumb bag of cells. It is not a battery pack anymore. Hence the fire can't spread. So because of our new approach, because we're the only company thinking in terms of cells and not the battery pack, we have some inherent advantages, but also some challenges that we need to solve. This way, it will take us 2.5 more months to comply with the regulations. And for the second point, yes, we need to partner with the bigger companies to go to the end customer. Hence, we're going step by step. Initially, 2 to 3 years only focusing on the fleet operators, build a strong network of stations first, prove our technology on the road, then move to the end user. But the thing confidence that we have is that when I close my eyes, when I see what vehicle I'll be using in the future, I know it is going to be an EV, but I also know that I won't be waiting at a charging station for 15 minutes. So I'm building this technology for myself, and I believe that the regular customers are also on the same. They also don't want to spend the time on charging station.
BMS बना है इसके साथ?
हाँ.
Cell level पे?
नहीं, तो हम लोग normal BMS को we have modified it to take our connectors.
So you've taken an off-the-shelf BMS
Yeah.
and your customers.
Yeah.
That's what you do.
So, definitely, very good technology what you're doing. In this case, one of the questions that comes to me is there's a difference between fleet owners and private owners, especially four-wheelers, two-wheelers, four-wheelers, and buses are an entirely different market. This will work for the buses really well, this will work for the two-wheelers, fleet owners really well. But what I realized was the four-wheeler owners don't actually want to go to a EV charging station. They all have a home-based EV charging station based on that 3-pin 16-watt, 16 amp plug that connects to their EV, and they don't want to do anything else. So I think it will be very difficult to penetrate some segments of the market, but you might be able to do it on the commercial segment as opposed to things like electric trucks, electric buses, the 2-wheelers, the 3-wheelers, that will work.
Yes.
There is the 4-wheelers, which are private cars or private scooters. That will be the areas where people would want to do it.
Yeah. So it is also the vision that we see that say 15 years from now, you will either charge your vehicle at home because your car gives you 500 kilometers of range, but you only have to go to your office, which is 25 kilometers away. But if you're coming to a public charging station, you want still that petrol pump, that 30-second convenience. So we don't want to compete with the home charging. We don't want that every four-wheeler owner comes to our station and charges. We are going to this other end of the market that needs to use the entire range every single day, that they don't want to wait 30 seconds, that does not have a parking space in their house where they can charge the vehicle and so on. So it is still a very huge market, and we don't want to target the other market as of now. And even in this very huge market, only the commercial customers for the first 2 years.
We wish you luck.
Thank you.